everyone. First, I'd like to thank the organizers for giving me the opportunity to present some of my recent work here. So, my talk is going to be about solution of mixed problem in Colombo. This is a teamwork presented by me and Bruce in collaboration with the Lilith Additional and Amadi and Zaid in laboratory for applied mathematics and scientific calculation, the Faculty of Science and Techniques of Newton. So the outline of my presentation, as we can see here, I will start with an introduction general of the problem. After that, I will give some definition and proposition that it will help us to improve our main result. In the third section, I will present the existence and uniqueness of the generalized solution of our problem. And finally, I will end with an application of this problem. So, on the path to finding a solution of a partial equation, we need some product of distribution, as we know that the product of two distributions is not always a distribution. In this case, we approach the solution. Uh, so the optimal solution for overcoming the problem that our theory of distribution is concerned with was offered by Jean-François Colombo between 1984-1985. Jean-François Colombo constructed an associative defensive algebra of generalized function G, which contains the space defined of distribution as a subspace and the algebra of certainty function as a subalgebra. This theory of generalized function of Colombo actually generalized the theory of Schwarz distribution. This new Colombo generalized function can be differentiated in the same way as a distribution, but where multiplication and other nonlinear operations are concerned. This is its significance that the result of all these operations always exists in this algebra as a Colombo generalized function. So the position of the problem is given by the system 1, as we can see here. This is the problem that this is a uniqueness of the solution. So, now we will present some notation. So, not a key is set of S function phi such that the moment 1 equal 1 and the other moment equal 0. And the equality of phi epsilon given by this equality. And also, we define the set of E is the set of U such that U is an x and limited to the second variable of x. And also the set of Monade function given by the definition star here, and the set of equilibrium function given by this definition of star. The Colombo algebra is defined as a factor set in this equality. So now we will move to present the definition of positive, negative, and bounded function in Colombo algebra. So we say that U is a globally bounded if there exists a strictly positive and representative U in the Monade function, in the set of Monade function of big U, and the integer number n, such that for all phi in A n we have this inequality with epsilon goes to 0. And also we define the a function U is said to be logarithmic growth if for any representative U in the set of Monade function of big U, and for any compact key of omega, it exists an integral number n such that for all phi in AN, and there exists a C strictly positive such that we have this inequality, right? When epsilon go to 0. Also, we defined, we say that a function is a strictly positive if if we have this inequality, and we say that function is strictly negative if we have inequality 7 when epsilon goes to 0. As a proposition, the definition 3 and 4 of the previous definition do not depend on the chosen representative, and also definition 1 of the previous definition does not depend on the chosen representative. It's easy to define these two propositions. And now we will transform the problem in Colombo algebra. So the transformation is given in the system 8, such that in the system 1 for each function we place a representative in the set of modulate function of this function. So we obtain this system 8. Now we will move to result. So the main result is given in the 1. Let's F, B, and C element of G. We assume that there exists F such that we have these inequality. We further assume that C is a globally bounded and the derivation comparing the to X of C and F have a locally logarithmic growth, and V is a globally bounded. Then for an initial data and H in G of R plus and the A in G of R plus times R plus, the problem 1 has a unique solution in Colombo algebra G. For the proof is defined in two sections: the existence for the existence less gamma I via the characteristic curve corresponding to lambda I. So the integral solution of the problem 8 is given by this equality. So we measure this equality by the infinity norm and use the Bloom lemma to obtain this inequality. And we know that all these functions are moderate functions, so we can say that this function is a moderate function. It means that we have this inequality, And for the first derivation also to xi, I between 1 and n, we obtain the same way. It means that the derivation of our integral solution is also in the set of moderate function. For the second derivative, also we can prove that this derivation exists also in the set of moderate function. This means that all kinds of derivation of the integral solution exists in the set of moderate function. It means that the function exists in Colombo algebra. For the uniqueness, let's use W in Colombo algebra to solution of the problem 8. Then there exists d epsilon 0, d epsilon 1 in a negligible in the set of negligible function, and d epsilon also in the set of negligible function, such that we have the problem 12. The integral solution of this problem is given in the same way in the first part of the existence. So we measure the integral solution by the same techniques. So we use the infinity norm and the Bloom inequality. We obtain this inequality, and we have that all these functions is a moderate function. It means that the difference between these two functions is a negligible function. It means that we have the difference in the set of negligible function. As an application, we consider the problem which present the propagation of V in this continuous medium given in the system 13 here, with C is equal to CL if X superior strictly in X0 and CL if X between 0 and X0. Also, initial condition U0, V0 are continuous almost everywhere, and there is in the feasibility of 0. So, as a result, let's U0, V0, V2 continuous function almost everywhere, bounded and 0 in the neighborhood of 0. Then the problem 13 admits a unique solution U, V in Colombo and Java G. Moreover, we have association between big U and small u, and also the association between big V and small v. And this is some evidence that we are used to prove our mean result. And thank you for your